Hello students, welcome back. So in today's session, we are going to cover NCERT section theory part from 3.23 to 3.24, and also we are going to cover some relevant examples. A small disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at SATHEE@itk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using generative AI, which is an experimental. Thank you. So in today's session, we are going to cover relation between radian and real numbers, and then the relationship between degree and radian measure, and examples 1 to 5. So relation between radian and real numbers. So just look at this diagram. In here we are having a unit circle meaning circle with radius 1, and we are having center at O, and this point, capital point A, is presented on the circle simply, as you can see. Now this OA will be your what? You are considering this side or this ray, you can say, or this line segment OA as your initial side of your angle. Now the radian measure from arc length, if you recall, the length of an arc of the circle will directly give the radian measure of angle that arc subtends at center. If you recall from the yesterday's class, that theta in radian is equals to what? Arc length by radius. Here we are considering a unit circle, meaning r is 1. So this, in this particular example, when we are considering our unit circle, the arc length will directly give me radian measure. Simple. Now just connect to this thing to the real numbers. So now imagine PAQ, which is your tangent to the circle at point A. As you can see from the diagram, A point on your circle, and you are having a line passing through this point A and touching the circle, and this line, we are saying this line is PAQ. As you can see, P is a positive direction, Q is in negative direction of your line. Clear? And this A is on what number? Real number 0. So you are initially standing on the 0 point. Now this segment AP represents your positive real numbers, and AQ represents your negative real numbers. Clear? AP your positive, AQ your negative real numbers. Now just establish some correspondence between radians and reals. How? So by this diagram, OA represents your radius, PAQ represents your line touching the circle, this unit circle at point A. Now just think that if we rope, meaning if we wrap this line, what line? This AP line anti-clockwise along the circle. Meaning, suppose AP represents your rope. Okay. Now what you are doing is wrapping around this circle, starting from A. Simple. You are taking your rope and placing on this circle circumference like this. Clear? Now, in anti-clockwise direction, obviously anti-clockwise, the opposite movement of the clock's needle. Now, every positive real number on AP line will correspond to a positive radian. Clear? Suppose if you take AP of say length half. Clear? Now if you wrap around this circle anti-clockwise direction, say this, your final position will be here, somewhere here, and this length is going to be half. Yes? Now this corresponds to what radian? Half radian from the definition. Clear? And the same we can do for clockwise movement, meaning AQ, for AQ. Clear? So in this way we will get our negative radians. This process also works in reverse. So every radian measure corresponds to a real number. So if you take any radian, this will also corresponds to some length, some arc length, and that arc length will be some number on your line, this complete line AP. Clear? Now, some key conclusions. So because of this direct correspondence, the radian measures and real numbers can be considered as one and the same. Why we are doing so? Because in order to generalize the concept of trigonometric ratios to the trigonometric functions, we require this thing. If you recall, if you have seen that the domain of your most of your trigonometric function, mainly if you observe in sine and cosine, so your domain is complete set of reals. Yes, but initially how we are defining our things? In radians, in terms of theta. Yes. So if you are talking in radians and if you are talking in numbers, both corresponds to the same thing. So this leads us to the generalization of trigonometric ratio to trigonometric functions. Now, fundamental relationship. A complete circle subtends an angle of 2 pi radians at the center. Clear? The same complete circle also subtends an angle of 360 degree. So 2 pi, one can say that 2 pi is same as 360 degree measure. Therefore, you can have your fundamental relation between radian and degree as 2 pi radian same as 360 degree. Which simplifies, if you divide by 2 to both sides, you will get pi radian must be equivalent to 180 degree. Now, you can establish your conversion formulas. So simply, so one is that in which you are converting radians to degree or degree to radian. Now radian to degree. So 1 radian from the above, pi radian is equals to 180 degree, this form. You can say that the 1 radian is equivalent to 180 degree by pi radians. And just assume that pi, this constant pi, is approximately same as 22 by 7, this fraction. However, be careful that pi is your irrational number, not a rational one. Here we are not saying that both are equal. We are approximating pi value to 22 by 7, this fraction. So using this value, you will get 1 radian is approximately in degrees is 57 degree 16 minutes. Clear? Now, degree to radian. So from the relation that 180 degree is equivalent to pi radian, you can get the idea that we are getting 1 degree is equivalent to pi by 180 radian. So 1 degree is approximately is 0.01746 radians by just using your pi value, which is 22 by 7. Okay. And we have seen that 1 radian is equals to what and 1 degree is equals to what. Then now you can find any radian equals to degree or any degree equals to radian. Clear? Now common angle conversion. The table shows the relationship between degree and radian measure for common angles. So what common angles we are talking about? Simply these, meaning 30 degree. So 30 degree is same as saying pi by 6 radians. 45 degree is same as saying pi by 4 radians. 60 degree is same as saying pi by 3 radians. 90 degree same as saying pi by 2 radians. 180 degree same as saying pi radian, we have seen this, and 270 degree is same as saying 3 pi by 2, and 360 we have already seen 360 is equivalent to 2 pi radians. Please do memorize these radian to degree or degree to radian. These are some standard and useful values. Now notational convention for angles. So when we write angle theta degree, it means the angle whose degree measure is theta. So this is for degree, in degree. If you are measuring in degree, the movement of your angle is in degree, then you are going to write theta. Then in superscript you are going to put a small circle which represents your degree, and you will say that theta degree. If you are not writing degree symbol, this little circle in superscript, then this will count as that you are counting your angle in radian measure. If someone is not putting any degree notation to your angle, then you will immediately observe or conclude that the given angle must be in radian. Clear? Now, important note on radian notation. So the word radian is often omitted when expressing angles in radians. So meaning that this pi, we are not writing pi radians, we just writing pi. So pi, so this is inbuilt. So we are going to we are not going to write anymore that this is your radian. It is already understood. So pi radian is equals to 180 degree. The same goes for pi by 4 is equals to 45 degree. So pi by 4 represents the radian angle. And in degree, we are going to use the degree notation, the small superscript circle. Clear? So you must have this understanding that pi represents the pi measure, radian measure, and pi by 4 also represents your radian measure. Now, some key conversion formulas. So radian measure is simply pi by 180 times degree measure. If you are given with degree measure, say you are having 180 degree, just put 180 degree in degree measure place, you will get the output in your radian measure. For example, if you take degree measure as 180, what will be your output? Simply pi by 180 multiply with 180. Both 180 will cancel out. The remaining term will be just pi, and this will be your radian measure. The same thing is written over here. The same goes for degree measure. So in order to get your degree measure, it is obvious that you first of all have your radian measure. So just plug your radian measure value and you will get your degree measure output. So please do memorize these two key formulas as you are going to need them. Okay. Now, some related examples. This will clear out your all doubts if you are having. So, convert 40 degree 20 minutes into radian measure. I hope that you all recall this is your sign for minutes. When you put this prime sign in superscript of any number which represents your minutes. Okay, so 40 degree 20 minutes. So just convert. Now the solution part. So solution. We know that 180 degree is equivalent to pi radian. First, convert the minutes into degree. So we know the conversion when we are having degree and radians. So in order to convert this 40 degree 20 minutes, we require the complete degree measure. So the first step is to convert minutes into degrees. So this 20 minute is what? Simply 20 by 60 degree. If you recall how we defined our minutes, 2 degrees. Yes. Now after simplifying, you will get this is equivalent to 1 by 3 degree. Now express the entire angle in degrees. Now, so 40 degree 20 minutes is same as 40 degree plus 1 by 3 degree. Simple. So this gives me 40 plus 1 by 3 degree. Now I am having this 40 degree 20 minutes equivalent to 121 by 3 degree. Now I am having my angle in degree measure. Now I can easily use my conversion formula or conversion rule, which says that if I am having degree measure, in order to get the radian measure, just plug degree measure in this right hand side expression, degree measure times pi by 180 degree. So the solution to be continued. So the radian measure is simply going to be 121 by 3 times pi by 180. So this, after simplifying, you will get this as 121 pi by 540 radians. So this 40 degree 20 minutes is same as saying 121 pi by 540 radians. Clear? Now this example. In here 6 radians given to you and you have to convert this 6 radian into degree measure. Simple. So now the solution part. Solution. So we know the conversion factor, which is pi radians is equivalent to 180 degree. To convert 6 radians to degrees, we are going to use what? This form which says that if you are having your radian measure, just plug the radian measure in the right hand side and you will get your output in degree measure. So radian measure times 180 degree by pi. So degree measure is equals to 6 times 180 by pi degrees. Now here we are using our pi value 22 by 7. Okay. A degree measure is simply 6 times 180 by 22 by 7 degrees, simple, which gives me what? The 6 times 180 times 7 by 22. After simplifying, you'll get 1080 times 7 by 22 degrees. Moving to next slide, which is equivalent to 7560 by 22 degrees, which is further equivalent to, after simplifying or cancelling out this factor 2, common factor 2, you will get 3780 divided by 11. Now convert the fractional part of the degree into minutes and seconds. So this fraction 3780 divided by 11, this is simply, if you divide by 11, you will find out that 343 multiplied by 11 plus 7 will be exactly 3780. So we are going to write this fraction in mixed form, which says that 343 whole 7 by 11, which is 343 degree plus 7 by 11th degree. You can also solve further if you want to break this 7 by 11 degree into minutes. Okay, so we are going to do that. So this 7 by 11 degree is simply 7 by 11 times 60 minutes. Why? Because 1 degree is what? 60 minutes. This will give you that 7 by 11 degree is same as saying 38 whole 2 by 11 minutes. Now moving to next slide, which is further equals to 38 minute plus 2 by 11 minute. One can also solve further for seconds. So now, yes, we are doing, so fractional part of the minute 2 seconds. So 2 by 11 minute is simply what? 2 by 11 times 60 seconds. Why? Since 1 minute is equal to 60 seconds, which gives me that 2 by 11 minute is 120 by 11 seconds, which is approximately, if you divide, we are approximating this fraction to 10.9 seconds. Now combining all the parts, you are going to have your 6 radians, approximately 343 degree, 38 minutes and 11 seconds. We have used this 10.9 round off integer, which is nearest integer is 11. So final answer is simply 6 radian is approximately 343 degree, 38 minutes and 11 seconds. Now this example, find the radius of the circle in which your central angle of 60 degree intercepts an arc length of 37.4 centimeters, and if you need, you can use your pi value as 22 by 7. I hope the question is clear. So this arc length already given to you is 37.4 centimeters. The angle also given to you. You have to just find out the radius in centimeters. Clear? Now solution. Starting with the given information. So arc length notation is simple, small l, is equals to 37.4 centimeter and your central angle is 60 degree. So angle is in degrees. So theta is 60 degree. So first of all, in order to use your formula theta is equals to arc length by radius, you must convert your degree to radian. So converting this central angle from degrees to radian. How? As we know that 180 degree is equals to pi radians. And we also know this form which helps us in converting degree to radian measure. If you know your degree measure, then just put degree value in the right hand side expression. So, and the output will be in radian measure. So, the form is radian measure is equals to degree measure times pi by 180 degree. From the given information, we know degree measure is simply what? Your 60 degree. So simple, your radian measure is 60 times pi by 180 radians. So 60 degree is equals to pi by 3 radians. What we used? What we are going to use is r, which represents your radius. R is L by theta. L represents your arc length and theta represents your angle in radians. Whenever you are using this form, this relationship between angle, arc length and radius, be careful that your theta must be in radians. Now, moving to next slide. So, just putting all my values, r is simply 37.4 by pi by 3. Substituting the value of pi already given to us, that what we are going to substitute pi as 22 by 7. So r becomes 37.4 times 3 divided by pi. Substituting my value, r becomes 37.4 times 3 by 22 by 7. Just simplifying the denominator, I am getting r as 37.4 times 3 times 7 by 22. So just calculate for the value of r. You'll get r is 785.4 divided by 22. On further simplifying, you'll get r is 35.7 centimeter. Therefore, the radius, when your arc length is 37.4 centimeters and the central angle is of 60 degrees, then the radius becomes 35.7 centimeters. I hope everything is clear. Now, this example. The minute hand of a watch is 1.5 centimeters long. How far does its tip, so tip of your minute hand, how far does its tip move in 40 minutes? If you need, you can use your pi value as 3.14. So the pi explicitly mentioned here. So you can use, if necessary, use 3.14. I hope the question is clear. Now to the solution. Solution. So starting with the given information. So radius of the circle, radius meaning the length of the minute hand. So just visualize how we are translating our question, this problem, into a circle form. Meaning this minute hand represents your radius, simple. So r is 1.5 centimeters. Now the time duration is 40 minutes. In order to get the distance, how far this tip moves in 40 minutes, first we have to determine the angle covered by the minute hand in 40 minutes in order to use our formula. Theta is equals to arc length by radius. So in 60 minutes, the minute hand completes one full revolution. Yes, which means 60 minutes is equivalent to say that my minute hand makes 2 pi radians or 360 degrees. Now, if 60 minutes gives me 2 pi radian or 360 degrees, then in 40 minutes, the hand turns through a fraction of a revolution. Simple. Meaning, in 40 minutes, I am going to make 2 by 3rd of a revolution. Simple. Clear? 2 by 3rd of a revolution. Meaning, now you can easily convert this fraction into radians. How? That theta is simply going to be 2 pi by 3 times 2 pi. Simple. So theta is 2 pi by 3 times 2 pi radian. Now continuing. So theta simply becomes what? 4 pi by 3 radians. Now it is easy to use the formula that arc length is product of the radius and angle measure in radians in order to get your distance or your arc length. So this L is 1.5 times 4 pi by 3. After changing this 1.5 into fraction, you'll get 3 by 2. So 3 by 2 times 4 pi by 3. So L becomes just 2 pi. Now just substitute your pi value as 3.14. You will get L, which is your distance traveled by the tip, twice of 3.14, meaning 6.28. Therefore, the tip of the minute hand moves 6.28 centimeters. I hope the steps are clear. Now, this example. If the arcs of the same length in two circles subtends angle 65 degree and 110 degree at the center, then find the ratio of their radii. In simple language, you are having your two circles. In one circle, you are making your central angle of 65 degree. In another circle, you are making your central angle of 110 degrees. And both corresponds to some arc length. And these arc lengths, these two arc lengths are same as given in our question. Yes. So if this much of information are given to us, then just find out the ratios of their radius. Simple. R1 divided by R2. You have to find out. Now the solution part. So starting with the assumption that R1 represents your circle with radius R1, R2 is another circle with radius R2. Now L be the length of each of the arcs given that they are of the same length. The central angles are given as, so theta 1 is 65 degree and theta 2 is 110 degrees. So I am assuming that R1 is for circle 1 and R2 is for circle 2. So same goes for theta 1 is for circle 1, theta is 2 for circle 2. Now first of all, we have to convert this degree measures into radian measures. What we know is 180 degree is pi radians. For theta 1, so theta 1 is 65 degrees. Since radian measure is degree measure times pi by 180 degree, using this formula, if you know your degree measure, you can easily get your radian measure. You just have to plug your degree measure in the right hand side expressions in order to get the radian measure. So this 65 degrees is simply what 65 times pi by 180 radians, which gives me 13 times 5 pi by 36 times 5. Now just cancel the common terms. You will get 65 degree is same as 13 pi by 36 radians. Now solution continues. Now for theta 2. So theta 2 is 110 degrees already given to us. Again, using the same form, as we are going to convert our degree measure into radian measure. In order to do that, we required the formula which says radian measure is equals to degree measure times pi by 180 degree. So if you are having a degree measure, just plug the degree measure value at, in the right hand side and you will get your radian measure as your output. So this 110 degree is 110 times pi by 180 radians. Just simplify your things, cancel the common terms. You will get 110 degree as 22 pi by 36 radians. Now we know the arc length formula, which says arc length is the product of radius and the angle in radians. Simple. So for first circle, L is simply R1 times theta 1. So L is going to be R1 times 13 pi by 36. And for second circle, L is R2 times theta 2, which gives me L is equals to R2 times 22 pi by 36. Since the arc lengths are the same, meaning both circles gives me the same arc length, so both must be same, L is equals to L. So we can equate both the expression. So we are going to get R1 times 13 pi by 36 is equals to R2 times 22 pi by 36. Now solution continues. So to find the ratio, meaning R1 by R2, you have to just rearrange your terms in the equation. So you will get R1 by R2 as 22 pi by 36 divided by 13 pi by 36. So R1 by R2 is simply solve your equation, this expression 22 pi by 36 times 36 pi by 13 pi. Gives me R1 by R2 as 22 by 13. And from this you can easily conclude the ratio of their radii. Radii is simply your plural for radius. Okay. Singular radius, plural radii. So radii ratio is going to be R1 ratio R2, which is 22 ratio 30. I hope all these steps are clear. So this is it. This is our end of this session. So thank you.